This lesson is over comparing and ordering rational numbers. Rational numbers are the numbers that we've been dealing with all week. So they include your natural numbers, which are your counting numbers, 1, 2, 3, etc. They also include your whole numbers, which is the same thing as the natural numbers. You just add 0. Your integers, which of course we talked about at the beginning of this year. And so that adds in negatives, and then of course your positives as well. And then lastly, to be considered the whole set of rational numbers, we also include terminating, which remember those are decimals that end, terminating and repeating decimals, as well as fractions. So basically, an easier way to think about this is any number that can be written as a fraction is considered a rational number. This graphic over here is a good way to think about it. Natural numbers are, again, the counting numbers. Whole numbers includes all the natural numbers plus 0. Integers includes all the natural, all the whole, plus your negatives. And then your rationals have all of that stuff plus decimals that repeat, decimals that end. They can be positive and negative, fractions, and again, everything in here. Irrational are things like pi and some square roots, which we'll talk about a little bit later in the year. So when we're comparing and ordering rational numbers, sometimes you'll be able to place some of them in the correct order without converting, but sometimes you'll need to change things to decimal form. So I'm going to take my my negatives first because I know that those are the smallest ones. So I'm looking for, remember the number line. This is 0 and -1, and this is -2. So the bigger the number is, the further left it is, the smaller it technically is. So -1/6 is the smallest, or sorry, -1.6 is the smallest number, followed by -1 1/4, because that's 0.25, followed by -1, and then -3/8. So I really didn't have to convert any of those to be able to put this in order from least to greatest. The last number is a positive, so I know it's got to be my biggest, and that's 2/5. When we compare, we're going to be using our less than, greater than, or equal symbols. So when we look at this, this is 1.2. I know that because I've memorized my benchmark fractions. So always look at your decimal places. That's a 2, that's a 2, so they're the same. That's a 5. This is technically a 0, which means 1.25 is greater than 1.1 1/5. So this is 2.3 repeating. Again, I know my benchmark fractions. That's why I knew that. If you didn't, you would just have to convert it. To take it out of percent form, I divide by 100, which means that I move it 2 decimal places. 2 1/3 is larger because that repeating means that I end up with 3s. This one has a 0 in the hundredths place. 3/8, excuse me, 3/8 and 37.55%. We need to convert those both into the same form. This is 0.375, which again is one of those you should have memorized. This one, we are dividing by 100. So when I look at this one has a 0 at the end. This one has a 5 at the end. So this one is less than that one. Mr. Davis gives each of his 5 students in his science class a different type of leaf. Each student measures the length of the leaf she or he is given and records the measurement in his or her ISN. The lengths are recorded as shown in the chart. we're going to list the links in order from largest to smallest. So first thing, I need to figure out what this is as a mixed number. So 8 goes into 21 twice, because 8 times 2 is 16, and that means there's 5 left over. 5/8 is one of those benchmark fractions that you should know. This is 2.625. That one's already in decimal form. This one is going to be 1.625. 4 goes into 11 twice, and 4 times 2 is 8, so there's 3 left over. 3/4 is also a benchmark fraction, so 2.75. The largest number up there is 2.75. So when we're listing, we always want to list it back in its original form. So 2.75 is taken care of. That's 11/4. And then it's going to be 21 over 8, because that is 2.625. Then we've got 2.5, and then 1.75, Melissa's, and then 1 5/8 would be my smallest. Frank recorded the low temperature for the last 5 days as follows. Which of the temperatures Frank recorded is lower than -8? So please remember your number line. So 1, 2, 3, 4, 5, 6, 7, 8. So this would be 9, 10, 11, 12. 12 is going to be lower. 7 would be right here, so that's not lower. 4 is definitely not lower. -9 would be right here, so that one's lower. And of course, a positive number doesn't work either. So -12 degrees Fahrenheit and -9 degrees Fahrenheit is colder. The table shows the amount of rainfall in inches above or below the mean for 5 regions in Oklahoma during a recent drought. We're going to order these regions from least to greatest to determine which one was the most above and the most below the median. The median is the middle number. So we have, 63 over 100, that is the same thing as -0.63. 4 over 25, if you do the division, that one's going to be 100 times 4. Sorry, I got to do this in my head real quick. 16 over 100, which is 0.16. So this is -8.16. You could also do this using division. I chose to take it out of 100, and the rest of them are already there. Now, I'm supposed to be listing them from least to greatest, so I really didn't have to convert that because I should have already known that that was going to be my smallest number based on the whole number. The next smallest number is -5.87, and then -63 over 100. So I've taken care of these, and then I'm going towards my positive. So 1.97, and then 3. Okay, so on these, we actually didn't really have to convert any of them because -8 is definitely smaller than -5. And then a fraction negative is definitely going to be smaller, bigger than a whole number. And then we just went to our positive forms. So which of the regions was most above and most below the median? Well, this one was the most above that middle number, and this one was most below that middle number. Please complete the assignment on the next few pages of your notebook.